This is tutorial 2, designing using spaces. Now that we understand the basics of quarter 1 from tutorial 1, we're going to look at importing and manipulating spaces from a spreadsheet. First of all, we need to understand another spreadsheet. This is the room definition spreadsheet, which essentially contains the client's brief or program. You'll see that I've identified here all the spaces which I expect to be contained within this building. The space also is assigned a level, 1, 2, 3, 4 or whatever. An area, in this case for the entrance and exhibition space, 150 meters squared, and it's defined with a shape, usually rectangular, but in this case we want this feature of the building to be a rotunda, so it's defined as a circle. Finally, we have the option of assigning a dimension to spaces. We don't have to, but it helps in the design process. So for example, we know that a optimum size for a naturally ventilated classroom is 7.5 meters and a corridor width is 3.2 meters. If we don't assign a dimension, it doesn't matter, as Q1 will import the space as a rectangle but in the format of the golden section. We also expect this building to be 5 stories high, so we've defined 5 levels for the building and also a floor-to-floor height between the levels, in this case 4050 meters, which gives us a cumulative height of the building. As before then, that spreadsheet needs to be saved as a CSV file, which is very straightforward through the usual dialog. So we have our site plan as before, and as before I'm going to hide the Google image just to make things a bit easier to understand. Also note that I'm always working on layer 0. I find this much less confusing than trying to assign layers to things. So to import our spaces, let's go to plugins, which is where quarter 1 resides, quarter 1 and room importer. The dialog then asks us to go and collect the spreadsheet that I've just illustrated. As you can see, it immediately drops all of the spaces into the model. You'll also notice that all of those spaces are now identified within the outliner by level and automatically by a room number. Now, this looks a bit busy, so what we're going to do is make things a bit easier to understand. So if we switch off the room text in layers, you can see that the model is much more easy to understand. What it's done is brought in the spaces in accordance with the level they were allocated in the spreadsheet, which, as I said before, doesn't necessarily need to be the right level. And we're going to start working on level 1, so the best thing to do is to hide all the other levels in the spreadsheet for the time being. So this is level 1, and we can switch the text back on. We can now understand the spaces. The spaces, you'll notice, are identified by the name I gave them in the spreadsheet. You'll also notice that there are 2 numbers here. The number in brackets is the area I defined in the spreadsheet. The number outside of the brackets is the area of the space that I'm working on at the moment. So for example, if I decide to manipulate this space or change it in whatever form I require or I wish, you'll notice that the active area is updated as I model. And doing this allows me to keep track of the original space in the client's brief as I'm designing. Which is much easier, obviously referring backwards and forwards to spreadsheets or to 2D drawings. Now I'm going to move some spaces. So for example, we'll take this office, we'll move it over adjacent to this facility. As you'll notice again that the office space offsets 150 millimeters from the production space, allowing internal walls to be automatically added later. If we decide we don't want the office space on this level, we want it on the level above, we simply move it and then identify it in the outliner and slide it into level 2. As you'll see, it's disappeared, and that's because level 2 is currently hidden. So as you can see, we can start to manipulate spaces and design the buildings by adjacencies and stacking. Here's the work in progress model. As you can see, vertical spaces such as staircases, lifts and plant risers are defined as single spaces which start from whichever level that they would do in your design. Sometimes it's easier to switch the text off to make rooms easier to deal with. Once you have finished designing your spaces in whatever shape, location or adjacency you require, the spatial BIM for your project will be complete, as in this example. As before, we can export an area or cost check at any time during the project. So we'll just do that now. Go into quarter 1, and plugins, area report. It's now asking us to pick up standard room data file, which we explained in tutorial 1. So these are the total areas for our project by GFA, or the inside face of the external wall, and by space. Look at the cost check. You can see that because we identified a cost per meter squared to various spaces, we now have a total project cost. That's it for tutorial 2. In tutorial 3, we will look at developing the concept design from this model, classification for unit class and BCIS, and delivering an elemental cost plan.